Hello everyone, we are from Team 18, and there are Nisrita Maurwa, Myla Finza, and Jackson Bakti Gusman. And in this video, we will talk about face recognition student using hard cascade algorithm. Abstract. Attendance is a form of arrival data collection that is widely used by people, especially students. However, to do attendance in a large number of students makes it difficult for lecturers to manage it, because it takes a lot of time and can cause attendance error. In this digitalization era, where many people have coexisted with technology, face recognition is a method that provides solutions to the problem of absenteeism today. And for introduction, firstly, background. Attendance tracking is essential in managing and monitoring classroom activities. There are several ways of tracking attendance, such as calling out individuals' names manually using fingerprints, using cards, and more. To improve efficiency and speed, new methods are needed to take attendance in the classroom. Computer vision technology could be a new way to take attendance for students in class, using a camera sensor to detect face when entering the classroom. The hard cascade method is used to identify faces in the image implement in the face detection phase. This method was chosen because of its ability to detect objects in digital image quickly and accurately. And for the problem statement, first, how can the hard cascade method could be implemented to create a face recognition system for student attendance? Second, how accurate is the performance of the face recognition system created using the hard cascade method to identify student face and mark their attendance? Third, what are the advantages of using a face recognition system for student attendance on campus compared to traditional attendance methods? 4, what are the challenges faced when implementing the hard cascade method for the face recognition system? 5, and what factor can affect the performance of the face recognition system, and how can be the system performance optimized? For research purpose, first, to implement the hard cascade method in developing a face recognition system for student attendance. Second, to evaluate the performance of the face recognition system using the hard cascade method. Third, to analyze the benefits of using a face recognition system for student attendance on campus compared to traditional attendance methods. And last, fourth, to identify factors that can affect the performance of the face recognition system and provide solution to optimize the system functionality.
The next one is face recognition. Face recognition technology has found application in numerous fields. It also can be used in field, especially for attendance system. Face recognition has become an important field of research in computer vision due to its vast application in security, surveillance, and various other fields. The proposed system applies the hard cascade algorithm to detect and recognize faces in real time. The hard cascade classifier is used to face detection, and the study proved that the hard cascade classifier system is a viable option for attendance system, especially in scenarios where a fast processing time is essential. One is methodology. The first one is data collection. The first step is to collect a face database that will be used to run the system. This dataset can be collected by taking pictures of the users who will be using the system. For experiments, we took data of 32 students from Minusmaya LMS website. The second one is pre-trained model. The system employs the hard cascade classifier, a pre-trained model to detect faces in the input video frame. The OpenCV library in Python is used to implement face detection based on the hard cascade. For face classification, using face recognition model, this model detecting or confirming the identity of individuals based on facial images. Third is system development. The system will capture users' face images, detect and recognize faces, and mark attendance accordingly. The steps system development are face encoding, face recognition, and attendance recording. Lastly, testing and evaluation. The last step is to test and evaluate the performance of the system. The authors test the overall system based on various metrics such as recognition accuracy, speed, and usability.
The next one is experimental setup. First is the dataset. We use the dataset of known faces stored as images in the known directory. Each image corresponds to a unique individual and is labeled with the person's name. 2 is real-time video capture. The experiment captures video frames in real time using the OpenCV library. The frames are processed to detect and recognize face. Third is face detection algorithm and recognition. The experiment utilized the face recognition library, which employs the pre-trained hard cascade classifier for face detection and computes face encodings and recognition. Fourth is attendance system. The detected and recognizable face is going to be input in attendance.csv. Next is experimental procedure. First is initializations. The experiment initializes by loading the known face images from the known directory. Second is face detection and recognition. The experiment continuously captures video frames from the webcam. Each frame is proceeded to detect faces using the hard cascade classifier and face classification using face recognition library. Detected faces are then compared with the known face encodings to recognize and label the faces in the frame. Third is display and evaluation. The experiment displays the video frames with rectangles around recognized faces and their corresponding names. The experiment continues until the user presses the Ctrl plus C key to exit. Next is evaluation. For face detection, accuracy is obtained for the hard cascade is 96.24%. For face recognition, the accuracy is 99.38% on the label faces in the world benchmark. The third is attendance system. Because the face recognition detected output is rapidly changed, the researchers make the system to do only taking attendance when the face of a known person is recognized for 5 seconds. For results and conclusion, the experiment showcased the effectiveness of the implemented face recognition system using the hard classifier and face recognition library. The results indicate that system can detect and recognize face in real-time scenarios. However, it is important to note that performance of the system is not too good because the recognized face changes rapidly on the same persons depending on various factors, such as lighting condition, pulse variation. So the accuracy is still quite lacking. In this way, the attendance system is more effective and does not take too much time. The system still has limitation because we don't use a proper database system. There is still a lot of room to improve this, especially in the data management. And considering this face recognition student attendance using our cascade algorithm is easy and quite efficient, this method is effective for use in the real-life application. Further research and improvement can be made to enhance the system robustness and accuracy. This may include more advanced face recognition technology.